Okay, in a group of 9 students, there are 3 females and 6 males. Um, how many, at least one girl. Okay, yeah. So 9 students, 3 females, 6 males, 5-member committees, exactly 2 girls, and 5-member committees, at least 1 girl. At least 1 girl. All right. Let's do it. This is going to be a challenging question. Okay. So let's think about it for a second. So we have a group of 9 students, 3 females, 6 males. We're going to pick how many different 5-member committees are possible if there's no restrictions. Well, the first thing to realize in this problem, order does not matter. Do you realize that? If the 9 people, let's just go, A, B, and C are the 3 females, and I'm just gonna say D, E, and well here, why don't I go male 1, male 2, male 3, male 4, male 5, male 6, and here I'll try to color code this. I'll do pink for girls. So female 1, it's like having a baby. Pink for the girls, blue for the boys. All right, 3 females, 6 males. Okay, you'll have different numbers than me. And if I want to pick a 5-member committee, well, I could say, okay, I'm going to pick female 2. I'm going to pick male 3 and male 6. Female 3 and male 2. There's 5-member committee. That is the same as, what if instead I said, oh, no, I meant I'm going to pick male 6 and male 2 and female 3 and female 2 and male 3. That's the same, right? That's the same 5 people. These 2 are the same, aren't they? It doesn't matter. Order does not matter. You tracking with me? This committee is exactly the same as that committee. They have the same 5 people. It doesn't matter the order they're picked in, right? Order only matters if they have different offices, right? If it was president, vice president, secretary, treasurer, whatever, right? Then it would matter because, person first is president. So then this would be a different situation if male 6 is the president instead of female 2. And the next one's the vice president, right? Then it would matter. So if you're picking people for different offices or different positions, if this was a race, you say, yeah, the 5 top finishers in this race, who were they? Well, female 2 came in first. No, male 6 came in first. And then the order matters, of course. If it's a race or if they have different positions or different jobs, then it matters. But if they're just all in the same committee, then order doesn't matter. Nobody cares. All right, so order doesn't matter. Okay, so what then? So that means whenever you've got a problem where order doesn't matter, we cannot use decisions options. You cannot use that thinking. That only works when order, because you might say, well, I can do it. You just got to pick 3 females, right? Five committee members. You just got to pick 5 committee members. You have 9 people. You just got to make decision 1. This is wrong. This is not right. But you'll be tempted to do this. You might just say, okay, look, I've just got to pick five committee members. I got to make 5 decisions, right? And I got nine total people. It says no restrictions. So there's just 9 people can be, and then 8 people, and then 7, and then 6, and then 5. No. Don't do that. That's not right. When you do that, you're making the order matter, and it doesn't, right? It doesn't matter who's first or second. Now, again, if these were different offices, president, vice president, then that would be exactly what we would do, because then the order would matter. It would matter, and I would just do decisions options. We do decisions options when order matters. So if it did matter, if these were different offices, president, vice president, secretary, or it was, positions in a race or sitting in a line, then the order would matter, and I would do decisions options. I would say 9, there's 9 people to choose from for the first spot, then 8, then 7. That'd be great if order mattered, but order doesn't matter here. You can't do that. What do? You can't do decisions options. So if you look at the notes, exam 4 notes, when the order matters, that's when you do decisions options. We're not doing that. We're down here when order doesn't matter. Let me show you the full thing. When order doesn't matter, what do? Here's an example. For choosing 3 out of 10, we're choosing 5 out of 9, right? We have 9 people total. Pick 5 for a committee. What do? You start at the 10, you multiply 300. So start with this number, multiply that many numbers, going down 1 each time, 10, 9, 8. That looks like decisions options, but then put this over a denominator starting at that smaller number, going all the way down to 1. So you put that over 3, 2, 1. That's the difference. When order does not matter, you've got to have a denominator to make it smaller, because if order doesn't matter, you have less options. So that's the difference. Order doesn't matter. So when order doesn't matter, we're picking what? 5 out of 9 for the committee. At least my numbers are, right? I'm supposed to pick a 5-member committee out of 9 total students. So how do you do that? Well, the notes just said start at 9 and do start at 9 and do 5 numbers, right? Start at 9, do 5 numbers. 9, 8, 7, 6, 5. Start at 9, do 5 numbers over what? 5 all the way down. 5, 4, 3, 2, 1. You with me? That's the denominator. So that's what we do. Let's hit the buttons on our calculator. So that denominator is what makes it different when order does not matter. I get 15,120 over 120. Oops, scribble that up. Divide by 120. No. I'm getting 126. 126. Interesting little question. Okay, now that's the first part. Now the second part, how many different 5-member committees are possible? There must be exactly, there should be an if in there or something. There must be exactly 2 girls. Exactly 2 girls. Now think about what that means. That means you've got to pick 2 girls out of what? Out of how many? Out of 3, right? You've got to pick 2 girls out of 3. And then what? Then, so there's five members. Then you've got to pick 3 males. Oh, I should have said girls. Let me say females. Females out of 3, and pick 3 males out of what? How many males are there? In my case, 6. Does that make sense? If we're going to pick a committee of 5 members where exactly 2 are girls, well, then basically you've got to pick 2 girls out of 3. I have 3 total females. And then you got to pick 3 males, right? Because we got 5 total on the committee. So we're going to have 2 girls, we got to have 3 males out of the 6 males that are possible. So how do you do that? Again, order doesn't matter. Remember, I can't do decisions options. Order doesn't matter. So, okay, so what am I going to do then? I'm going to go 3, start at the bigger number, do 2 numbers, right? Over 2 times 1. Then, so that's going to be times, and then start at 6, do 3 numbers. 6 times 5 times 4 over 3, 2, 1. So this is going to be, if you multiply this on your calculator, this is 6 over 2, this is 3. So it's 3 times, and this will come out some big number, 120, I think, over, right, yeah, over 6, which equals 20. 3 times 20, which equals 60. That's not easy. Let me pause there, and we have the third part coming, which is even harder. But are you tracking with me on that? Do you see what I did there? You're going to pick a 5-member committee with exactly 2 girls. That means you've got to pick 2 girls out of 3. So I have 3 total females. And you got to pick 3 males because you're going to have 5 people on the committee out of the 6 males. So how do you pick 2 out of 3? Well, that's what I'm saying. When order doesn't matter, you start at the first number. Remember how that, getting the hang of that? Start at 3, write 2 numbers. That's what it says down here, right? Did you get that in the notes? Right? Start at 10, multiply 3 numbers. Start at 10, multiply 3 numbers. 10, 9, 8. And then divide by that second number all the way down to 1. That's how we do it when order doesn't matter. So here we start at 3, do 2 numbers over 2 on down to 1. That's 6 over 2, 3. And here, start at 6, do 3 numbers over 3, 2, 1. 3 times 20, and we multiply those together. Why? Because every possible choice of a couple of females can be paired with a choice of 3 males. All the different ways you can do this and all the different ways you can do that must multiply together. Is that making sense? They must multiply together. If you want all the total possibilities, they must multiply together because they go together like that. All the different possibilities for how many female, you got to pick a group of 2 females and you got to pick a group of 3 males. And for every possible different, there's 3 different groups of your 2 females, and there's 20 different groups of your 3 males. And so those have to multiply. There's 60 different total possible ways to make this committee selection. And then coming down for the last part, how many different 5-member committees, if there must be at least 1 girl? Well, this is pretty darn tricky. This is like a bonus question. Maybe you're not feeling like it's a bonus. And here's the trick. At least 1 girl. Whenever they do at least, what does at least 1 girl mean? It means 1 or more girls. That's what it means. It means 1 or more, at least, at the lowest, at the least 1, means 1 or more girls, 1 or more. Okay, well, the best way to do this problem is to think this way. What's the opposite of that? I know it seems fun, like why am I doing this? At least 1 is tough. So instead, think about the opposite. What's the opposite of 1 or more? What is the opposite of 1 or more girls? No girls, right? Isn't that the opposite? Isn't that the opposite of 1 or more girls, of at least 1 girl? The opposite is no girls, right? Figure that out and then subtract, because that's easier. Let me show you. So no girls. So if you're going to pick a 5-member, so pick 5 members, no girls. So that means all 5 are boys. All 5 are boys. Okay, so how do you do all 5 are boys? Well, how many boys are there? Out of, how many did I have? 6. I had 6 males, 6 boys. Out of 6 boys, pick 5, right? So what does that mean? That means start at 6, do 5 numbers. 6, 5, 4, 3, 2, over 5, 4, 3, 2, 1. You with me? Order doesn't matter. That's how we do order doesn't matter. We start at 6. Getting the hang of this? Start at 6. Write 5 numbers. Right? This right here is 5 numbers. So I started at 6. I wrote 5 numbers over 5, 4, 3, 2, 1. So that's actually pretty easy to figure out because the 5, 4, 3, 2 cancels 6 over 1. It's just 6. It's just 6 over 1. It just comes out 6. Okay, but that's not our answer. Careful, that's the opposite of our answer. In other words, they said, how many 5-member committees are there with at least one girl? Well, that means there's 6 committees. There's 6 committees with no girls, no females, right? This was the opposite, is no girls. So that means there's 6 committees with no girls. There's 6 different committees that have no girls on them. Okay, so all the rest of the committees have 1 or more girls. Are you with me? There's 6 different committees that have no girls. So all the rest of the committees, other than those 6, have 1 or more girls. Well, how many is that? Well, back on step 1, remember, we figured out all the possible committees. I know this is getting pretty complex. This is the challenging problem. So from part 1, there's 126 total committees. Are you with me? That's what we answered in part 1. How many total committees are possible? 126. So if there's 126 total committees, we got that answer from part 1, and 6 committees have no girls, then 126 total minus the 6 committees that have no girls, there must be 120, right? Subtract those, with 1 or more girls, at least 1 girl. There we go. That's not easy. We subtract. We get it by subtraction. That's pretty tricky. Let me run over that again. To at least 1 girl, they want to know how many committees have at least 1 girl. That means 1 or more girls. So it's better to do the opposite. What's the opposite of 1 or more? None. And how do you figure out how many committees have no girls? Well, that means all boys. So that means out of the 6 boys, at least I had 6 males, pick 5, right? For the whole committee of 5, make them all males. So that means start at 6, write 5 numbers. Start at 6, write 5 numbers, over 5 on down to 1. Cancel all that out. That's just 6. That means there's 6 different committees that are all guys, no girls. So then grab your answer from part 1, 126 total committees. 6 of them have no girls, they're just all guys. Subtract that. That means 120 of them have 1 or more girls. So that's pretty hard. There we go.